Okay, welcome again. So in the last video I discussed about the solution of quadratic equation by factorization and using formula. So now today we are going to discuss about the nature of the roots of a quadratic equation. Nature of the roots of a quadratic equation. Nature of the roots of a quadratic equation. So today I am going to discuss about the nature of the roots of a quadratic equation. So if the quadratic equation is ax square plus bx plus c is equal to 0, a is not equal to 0, then its solution can be found out by using the formula x equal to minus b plus minus root over b square minus 4ac by 2a. This is the formula by which you can solve a quadratic equation. So here this part plays a very vital role to know the nature of the roots. Before solving the quadratic equation, we can check this one and we can come to know that this equation is solvable or not, having real roots, not having real roots, or other natures of the roots. We can find out by using this one. And this part, b square minus 4ac, is known as the discriminant of the quadratic equation. So let us discuss about this. So b square minus 4ac, this is in inverted comma, b square minus 4ac is called the discriminant of the quadratic equation, a x squared plus bx plus c equal to 0, a is not equal to 0. Okay, now let us discuss the different forms of this b square minus 4ac. So number one, if b square minus 4ac is equal to 0, then the roots are real and equal. So we see that if b square minus 4ac equal to 0, then both the roots, a quadratic equation always having two roots, then both the roots will be real and equal. Number 2, if b square minus 4ac greater than 0 and a perfect square, the value you get is a perfect square. Suppose b square minus 4ac you get 4, then it is a perfect square. So and it is a perfect square, then the roots are real, unequal and rational. We see that if b square minus 4ac is greater than 0 and that value is a perfect square like 4, 9, etc., then the roots are real, unequal and rational. So we can go to the next number. So I make it 3. So same condition and not a perfect square, like this, b square minus 4ac greater than 0 and not a perfect square. Suppose you get the number not a perfect square. Suppose you get the number b square minus 4ac is like 5, which is not a perfect square. Then the roots are real, unequal and this is become irrational. That is the difference between these two conditions. That is, one is rational, another is irrational. If we combine all these three, we get another point. If b square minus 4ac greater than equal to 0, then the roots are real. If this is happen, b square minus 4ac is greater than equal to 0, either equal to 0 or greater than 0, then the roots are simply real. We are not going to mention it is equal or irrational or rational. If this condition is there, then we call it the roots are real. Generally, if the equation is given, we get the actual result. It is a equal or a rational number or irrational number like this, but in algebraic expression if the unknowns are there, then we may have this type of condition, then we just say the roots are real. And number 5, if b square minus 4ac less than 0, then no real roots exist, or we may say that the roots are imaginary. The roots are imaginary. The word imaginary will be clear in the higher classes. Here b square minus 4ac get less than 0, then the roots, no real roots are exist. There is no real solution of this equation. Now we will discuss with example. Discuss with example. So first one example is number 1, 2x square minus 3x plus 5 equal to 0. Let us discuss with this one. 2x square minus 3x plus 5 equal to 0. So here comparing with x square plus bx plus c equal to 0 is not equal to 0. We get what we get. So here in place of a, 2 is here. So a equal to 2. In place of b it is minus 3, and in place of c it is 5. So just we check this one, b square minus 4ac, that will be equal to minus 3 whole square. Okay, first you find a, b and c by comparing the given equation with ax square plus bx plus c equal to 0. You get b square minus 4 times ac. So this will give us 9, and this will give us 8 for the 40. This is 40. That is equal to minus 31. This is less than 0. So b square minus 4ac is less than 0. That means no real root exists. So no real roots exist. So as there is no real root exists, so we need not to solve the equation because we cannot have the real roots. So my next example will be 3x square minus 4 root 3x plus 5 equal to 0. Next number 2 is 3x square minus 4 root 3x plus, okay, I am taking this one as 4. Okay. Comparing with ax square plus bx plus c equal to 0. A is not equal to 0. Exactly same way we are doing. Exactly same way we can do this one also. Okay, I wrap this part. Then here you can see that in place of a this is 3, in place of b this is minus 4 root 3, and in place of c it is 4. Now we check b square minus 4ac. So first substitute for b. This is squared minus 4 times 3, 4. So here if we square it, 4 4 is a 16, 16 3 is a 48, minus 48. So here we get 0. So b square minus 4ac equal to 0. In this case, the roots are equal and real. The roots are equal and real. So here we get the, if we solve the equation, we will get the same value for x. Same value for x. Both the value of x will be same. So in this case we get the equal and real roots. So we'll go for the third example. So first one having no real roots, here real roots and equal, and next third one I'll try to show that the roots are real but unequal. So I'm going to take another example, that is 2x square minus 6x plus 3 equal to 0. So again we comparing this given equation with ax square plus bx plus c equal to 0, and we get here in place of a, what we get? In place of a is 2. Okay, here in place of b what we get? In place of b we get minus 6, and in place of c we get here 3. So again we are going to calculate b square minus 4ac. Okay, let's see what happened here. So here it is b square b square is minus 6 whole square minus 4 times ac. So this is 36 and 24. So here we get 12, which is greater than 0. 6 minus 6 whole square will be 36. 4 to the 8, 8 to the 24. So 36 minus 24 is 12. So the roots are real and unequal. So roots are real and unequal. In this case we will get both the roots, but they are not equal to each other. So these are the three different examples where I saw the root real, there is no real roots, then the roots are equal and real, and roots are unequal and real. So in the next video I will solve few word problems based on quadratic equation. So that's all for today. Thank you for watching. Like, subscribe and share. Thank you.